Thank you so much for the invitation to participate in your Sea and Society talks, for your kind introduction, Malin. It's my pleasure to be here. I have about 10 years of hands-on experience with citizen science, theory and practice of citizen science, and I might be what you call a passionate realist. So that's why I'd like to talk to you about the myths and realities of what comes into play when we practice citizen science. So citizen science, in fact, is a very old tradition, but in recent decades has seen an acceleration due to the diffusion of information communication and technologies. And there's really no shortage in terms of terminology, how to describe what is really an overlapping phenomenon in terms of the key role of citizens in generating data and knowledge. There is also an enormous amount of overestimation of what citizen science means and can do for us. There's also some underestimations. And in fact, this is the myths and realities I'd like to reflect on with you today, and to consider how we can dispel the hype from the hope, and how we can move from these myths and really turn the potential of citizen science into practice and into tangible outcomes. So I'd like to share with you 5 myths and see how in reality we can deal with them. So here we go. So myth number 1 is that citizen science is the contribution of the public to science via data collection. Well, actually, it's broader than that. There's a whole landscape of citizen science approaches, and the suitability of which approach we use depends really on the actor dynamics and also on the agreed outcomes. So in terms of the contribution of citizen science to science, we are all familiar, I presume, to greater or lesser extent with the scientific method. And citizen science, in fact, can play a role in every single step of the scientific method, not just in data collection. From the theory of citizen science, this has sometimes been grouped into saying there are actually these different ways in which citizens can contribute. We can call the more limited forms contributory projects, where citizens are invited merely to be involved in data collection or data analysis. Collaborative projects open up the process a bit more, inviting people to design and also to disseminate results. And then the co-created citizen science projects, they go all the way of really co-creating science throughout all the steps of the scientific method. That's not the only way we can think about citizen science as broader than just the contribution to science. We have help here from colleagues Schäfer and Kiesinger, who've drawn up this typology of citizen science projects. And it really draws attention to 2 key dimensions. Number 1, what is citizen science really used for? Is it used for answering a scientific question, or do we go actually to the application of the co-created knowledge in terms of interventions in socio-ecological systems? And secondly, the other question is, well, who's in the lead here? Is it research-driven, or is it a more bottom-up initiative driven by members of the public, local communities? And there we see those bottom-up initiatives take us more into action projects, things that people who really try to exert change on a local level. Citizen science also has a relationship with policy, can actually contribute to policy, not just by producing better science, but also in more direct ways of being involved in different steps in the policy cycle, not only by providing data and new knowledge, but actually also informing about issues, feeding those into the policy cycle, but also monitoring the impact of policies, compliance with environmental obligations, for example, are key examples here. And just to substantiate just how strong that relationship between citizen science and policy already is, here I've featured work of the colleagues from the Joint Research Center in Istria in Italy, who a couple of years ago actually mapped on a European level how many projects are there, and there was some 500 or so. And then the blocks represent the thematic focus of these projects that actually already have a strong relationship and a contribution to policy. And we see that there's a heavy emphasis on citizen science projects focused on biodiversity, nature, and landscapes, followed by air quality and water. So myth number 2 is open the gates and here they come. Just because we are passionate about citizen science, everybody else is going to join the force. And actually, well, we see that engaging stakeholders in citizen science isn't that easy, or certainly isn't always easy. So we actually need to pay some attention, not only that there's competition for people's attention, they have many other things to do than to be involved with us in citizen science, but also that the different stakeholders we are engaging in citizen science, different citizen groups, communities, but also we need scientific expertise. And as I said before, we also try to have links with decision makers. All of these different stakeholder groups, in fact, have their own motivations to participate in citizen science. From our research, we have seen that many citizens, many members of the public that participate are really driven by contributing to society, contributing to science, but also on a personal level want to be part of a community, want to join like-minded people. At the same time, they're also very interested in seeing what does it all lead to, what happens with my data, what happens with my contribution, the time I invest, which decisions are taken, what does this all result in? So that's a very strong motivation, not only to participate initially, but to remain engaged. From the scientific community, we see indeed that there's really increasing interest in what citizen science can mean for their scientific practice. Often there's a strong focus on data, but also at this stage, we still see that the scientific community is also very eager to learn. How do you do citizen science? How do you involve citizens in different steps of the scientific methods? And for decision makers and policy makers, the motivation on the one hand is to explore what can this new data stream mean for my management of the environment, whichever their responsibilities are, but also to explore to say, hey, what is this a new form of public participation? So we see there are quite diverse motivations at play. And moreover, beyond those and beyond the competition for attention from people's work and entertainment and all kinds of other activities, we also have to pay tribute to the fact that the motivations are often contextualized or framed by the socioeconomic settings in which people, members of the public, live. And that greatly determines the extent to which they can really free their time for participating in citizen science. In some of the poorer parts of the world where we have worked with local communities, rural communities, it's really an opportunity cost to free their time for citizen science. So all of this means that we really need to understand what drives the different stakeholders, particularly different distinct groups of the public to participate, and then shape our engagement methods and strategies accordingly, and also to make sure that they're able to participate over time and not once. Myth number 3. So citizen science is plug and play. You build a few apps, you install some sensors, and you have nice visualization on platforms. Well, yes, technology is a key enabler in what's happening with citizen science, but we actually really need to know what we need in each case, and technology alone is not enough to make citizen science a success. So actually, we need to think about how we set up citizen science activities. There are very distinct ways. Again, a whole range of co-design methodologies alone, great extents to which we can engage stakeholders when we set up such initiatives. But ultimately, it's relationship also with what we have in mind, what we're trying to get out of it. As I said before, is that the science-driven approach mostly focused on data. How much do we want to open up that process? So it's a question of co-designing for the specific impact we have in mind. And so when we set up these initiatives and we invite people to either a science-driven or a more policy-driven form of citizen science, sometimes there are more questions than answers. So who actually decides what gets measured? Is it the scientists, the citizens, the policymakers, or is it a combination? Is it a discussion? Is it a negotiation? And for those citizen science projects that have these stronger links with policy and decision-making processes, then it's a question of, well, what of the evidence that produced as part of citizen science actually counts in the decision-making process. How does it count? Is it taken on par with other scientific evidence? And who decides how this evidence counts? So quite a number of questions to consider. And that means we're actually also moving away from, mere production of scientific knowledge to actually innovating governance towards more participatory forms of governance. And again, there's not just one size fits all, but we can distinguish different forms in which, the data, the knowledge, and also the insights, the engagement of the public can play out. We've distinguished here between, in terms of participatory governance, that's perhaps more focused on the mere environmental monitoring, more collaborative forms of planning, and then even environmental stewardship, where there is a full realized dialogue and shared responsibility for natural resource management. That leaves us moving on to myth number 4, which is more focused on the data and an often mentioned concern as well. Great, the citizen science thing, but actually the quality of citizen science data, isn't that really poor? Well, data quality, of course, is an issue in citizen science and it requires careful attention. But, the same is true for traditional science. And so there's many ways in which in citizen science we put data quality practices. So we can distinguish at least 3 forms I've learned of dimensions of data quality. Partly we can also say, well, who decides what the data quality is? Isn't data quality in the eye of the beholder? My colleague Joan Mazot from CREF, who's really the expert in the field of citizen science data quality, has hopefully distinguished between 3 different perspectives. The consumer perspective argues that data is of good quality, that is fit for use or the purpose that we're trying to use it for. It's either meeting or even exceeding the expectations. So it satisfies the requirements of the intended use. When we take the producer's perspective, then we can define data quality in terms of fit for use rather than fit for purpose, primarily in terms of the intended use for operational decision making. So data has to satisfy the technical requirements defined to produce the data. And then the standards perspective tries to come up with a more neutral, objective, let's say, in some way, inherent set of characteristics that quantify and fulfill requirements. So the usefulness, accuracy, and correctness of the data for its application is, the definition of data quality from this perspective. So many ways of defining data quality, but what does it mean in citizen science in practice then? Well, for one thing, an often practiced approach is training citizen scientists in how to collect the data, how to do the monitoring, how to use specific equipment, how to follow a protocol. So that's a very important first step. But also, once data has been produced, it can be checked and is verified, and that can even be done by peers. So by other citizen scientists, those that have more experience, and it's a good way for new contributors to learn from these interactions, and themselves they can become more experienced. We also, of course, have the option to have data validated by experts, by scientifically trained experts, and who are interested actually in analyzing and using the data, and that's typically the scientists. And finally, we have the automatic validation by apps, either limiting or immediately controlling the entries. So we have various algorithms that can come into play to help safeguard data quality. And all of these steps are really important, but perhaps on top of this, I would add, it's communicate about the fact that these data quality validation measures are being taken to really create trust and confidence in the citizen science data that's being produced. Finally, myth number 5. It's this great expectation that citizen science is going to solve all our problems. It's the panacea. Yes, I would like to think so too, but on the other hand, I know that there's lots of things we still don't know how to get right when we practice citizen science. So the science of citizen science is still evolving and is providing cumulative insights on how we address the existing challenges that we have when we practice citizen science. Well, what are some of those challenges apart from the myths-related ones I've mentioned? On the one hand, we have the awareness challenge. Many members of the public are simply not aware that citizen science exists, that they have the opportunity to monitor and help address issues in their immediate environment. And similarly, so are many public authorities, small, medium enterprises, civil society organizations are just quite unaware of the opportunities that citizen science can provide to decision making, creating business opportunities, and improving environmental management. Secondly, is the acceptability challenge I mentioned before, concerns about data quality and how that limits the use of generated insights in decision making. We see some public authorities are hesitant to accept data from citizen science initiatives for those reasons. And we need to really make sure, therefore, that we safeguard the quality of citizen science activities and showcase how it can add value and how that can help them improve the uptake of citizen science. Sustainability is a really fundamental issue for many citizen science initiatives. And that is the case because so many, the majority of them are project-based. Once the funding stops, then many of these initiatives stop. So it's really difficult to sustain the momentum in terms of stakeholder engagement, but also to maintain infrastructure that's been built to collect the data, to share the data, make it available online, and also to scale beyond the initial effort. So these are quite some challenges, but at the same time, we can also say, perhaps not quite the panacea, but if we look at the SDGs, the Sustainable Development Goals, as sort of sketching the challenges against which we are up and which we're trying to address as a global community, we can actually see that there is a silver lining in terms of how citizen science can concretely contribute to monitoring the SDGs. Based on a detailed mapping exercise that we have done under the lead of my colleague Philip Fraser from IASA in Austria, we carefully looked at all the SDGs and we scouted for all the citizen science projects we could possibly find to see which SDGs can already benefit from monitoring through citizen science or have the potential to be monitored in terms of really looking at the methodology for each indicator. And what we found that the greatest contribution of citizen science data to monitoring SDGs is for 4 specific SDGs. SDG number 13, Life on Land, SDG 11, Sustainable Cities and Communities, SDG 3, Good Health and Well-being, and number 6, Clean Water and Sanitation. So if we take a slightly closer look then, what you see on this map here are all the 17 SDGs and the indicators listed, and then the legend shows in green where we have found concrete projects already currently contributing to monitoring the SDGs. And notably for this audience, very interesting is that SDG number 14, 1.1, monitoring coastal eutrophication and floating plastic debris density. There we have found more than one citizen science project. So that has a green tick in the box, if you like. The yellow ones are where there's potential citizen science could contribute, carefully looking at the methodology of what the indicator requires, and quite a number show no alignment. These are the gray boxes. But overall, to summarize, in principle, for at least one or more indicators, citizen science could contribute to monitoring the SDGs. It's already or could contribute to 40% of the environmental indicators, and overall, citizen science could contribute to 33% of the indicators. So that's actually quite a substantial contribution. Mind you, that's the monitoring. for the SDGs, and to really fully exploit this, we need a roadmap, which we have outlined in this paper, so that it's clear what the steps are to really make sure that citizen science data is accepted and really incorporated into the official reporting by national statistics offices. So to conclude, I hope I haven't, been too realistic, perhaps. But I am passionate about citizen science, but I am also realistic. So I'd like to stress again, citizen science is not just about data. It's also not just about science, and it's definitely not a simple plug and play solution. It's really a multi-stakeholder, multi-dimensional phenomenon that can have very diverse results and impacts. So it's a very rich picture that we have behind this simple term of citizen science. It can help society be better connected to science, tap into local knowledge, but also foster very new relationships between stakeholders and combine knowledge in new ways and innovate forms of governance. So this big potential and the expectations of citizen science to enable knowledge-based interactions among stakeholders actually require a really careful approach, so living up to those expectations. And that's the same as for science and co-management of natural resources. We can't just pull this out of a hat. We need to carefully think of how we approach this. And the same is true for citizen science. So therefore, just to finish off, I would argue that the citizen science and the results it produces is only as good as the process by which it's implemented. And that requires us to really build on the lessons that are continuously being learned and shared, and make sure we apply best practice in citizen science. And the field of citizen science is evolving really fast to consolidate this and to share this with the wider community. So thank you so much for your attention, and I look forward to the discussion.